Hey, CrossFitters, welcome back. It's Coach Bob, and today we're going to be looking at exercise and the relationship with carbohydrate metabolism. So today I got a hold of a fairly current book on microbiology, and we've got 21 chapters of all the biomechanical stuff that's happening inside of our bodies while we exercise. And I am stoked to be able to share some of what I'm learning with you a little bit at a time, because there's a lot in this book. But we're going to take it one step at a time. We're just going to incorporate this in a little bit of our learning as we go. My thought is that if we can better understand some of the mechanisms and how our body deals with exercise and nutrition, then we could be more informed, making better selections on the types of exercises we want to do, the amount of exercise, and the intensity of the exercises, so we can stay fit, stay healthy, and be the best CrossFitters we could be. All right, let's take a look. We got chapter 2 today that we're going to be looking at. We're covering exercise and the regulation of carbohydrate metabolism. So I'm not going to go in great detail, but I want to get us at least thinking about some of the microbiology. What's happening when we're exercising. And this was pretty much right after the introduction. This is chapter 2. And I think it's interesting, first of all, that, these leading scientists are placing carbohydrate metabolism really at the top of the list of something that they feel is what we need to know. Okay, so what I hope to do in here is to give us a sense as to why this is an important topic, and more so about like just getting us to start thinking about how our current activities that we do and choices and decisions that we're making in our life can be better informed overall. So join me in just a couple minutes. We'll go through this together and see what we can learn. Okay, so exercise and the regulation of carbohydrate metabolism. And I highlighted a few things here just to keep us focused. One of the things they start with is that, our ability as humans to perform endurance running has likely contributed to our evolution over time from primates. Being able to have high levels of physical activity that were required to evade predators as well as obtain food. And I think I've got a little picture here for us to just kind of think about it. So when we look at, what it may have been like, if you could not go to, your local grocery store or get meals delivered and there was no DoorDash going on, we weren't going out to eat. We had to go and hunt, and whether we were hunting or planting and gathering foods or berries or whatever it was, there was a good bit of work that was involved in just basic survival. And so, I just wanted us to kind of start there a little bit and just kind of think about, the amount of intensity and exercise and effort that went into just being able to sit down and have a meal. Okay, start here and then go from there. All right. Another kind of thing I want to do is I want to kind of set the overall timeline here. Now, if we think of like the global solar system kind of a thing, we're like 4.5 billion years or 5 billion year time frame here. So, quite a lot of time going on here. But let's look at the timeline for human beings. Okay, so it says it's taken humanity 4.5 billion years to discover that is 4.5 billion years old. All right. So just a little thought provoking there. So the human timeline over the last 5 million years, I mean, we're talking on the order of millions of years here, guys, right? So it says 3.7 million years, first humans and so on. So we spent a lot of time without DoorDash, without being able to go to the grocery store, without, the modern kinds of things we have to prepare food, microwaves, and so on. I mean, a lot of what we were doing here was very similar to this picture for millennia, millions of years, right? So millions of years, we were out there in the wild doing the best we can to survive. Anyway, I wanted to kind of set that context because when we look at our metabolism, it's really designed and built to survive that kind of environment for the most part. And so in order to maintain those high levels of physical activity, our working muscles required increased substrates for generation of adenosine triphosphate, or ATP. A major substrate for the working muscles is carbohydrates. And with the source being inside of the muscle itself in the form of glycogen, and also another source of glucose coming from the blood, right? So we know of blood glucose if we ever had a blood test, and if we were ever tested for either being pre-diabetic or, high sugar levels in our blood. So the breakdown of the glycogen from the muscles and the regulation of the glucose in the muscle are highly regulated process. And so we're just going to kind of take a look at that. So they kind of go on and compare it to our current lifestyles, because our current lifestyles are, we have to admit, predominantly sedentary, especially when we compare it to relative to our history, right? Where we spent most of our time being very active. Now we spend most of our time not being active. And couple this with the intake of excessive amounts of carbohydrates, the American diet, plates of pasta, and on and on. It's just led to metabolic diseases such as we have not seen before, like type 2 diabetes. And when I say not seen before, not seen for millions of years, right? So this is an endemic now, today, and a problem we have today with type 2 diabetes. And it says, on the other hand, and I think this is important, especially for us when we are making our health and our fitness a priority, to hear and that exercise has a beneficial effect on carbohydrate metabolism. And as a result, exercise is a well-established tool to prevent and combat type 2 diabetes, and the molecular mechanisms that mediate the effects of exercise to increase skeletal muscle glucose uptake and increase insulin sensitivity in healthy people and people with type 2 diabetes are also discussed in here. So the rest of the chapter goes on and it talks a lot about the mechanisms under there. And when you look at like the microbiological stuff that's really going on at a very detailed level, the microbiologist is trying to understand those mechanics, right? And you might think like, well, I can't measure this in my day-to-day life. I mean, I might have one of the wearables where I get a little bit of an indication, but I'm not going to be measuring necessarily my blood glucose level, or more likely, certainly not going to be measuring, the GLUT4, the signaling into being able to get glucose into the cells to do work. I mean, just not going to know, right? So it's a little bit confounding that you have all this detailed information and the microbiologist is helping us understand it, but what good can we do with it, right? If we can't measure where we're currently at. Well, in the big picture, though, we can understand some of the major parts of, how activity and exercise is causing these things to either upregulate or downregulate. And just kind of like knowing that and knowing that we have a positive effect on these different systems. It doesn't necessarily matter much, if it's, what the actual millimole reading is on any particular hormone or the endocrine system or anything like that. Just knowing that muscle glycogen is involved in the delivery of this very important energy system to life helps us to value having an active lifestyle where using our muscles to do good helps us to be energetic and to do useful things in life. So we may not really kind of need to get into the nuts and bolts of the microbiology, but understanding that can help us to value the activities and the things that we do in life so that we can make better decisions in our life and continue to thrive and to live a healthy and a happy life. One important aspect of insulin, right? So insulin is going to be that part that's released from the pancreas, and it basically is going to have a myriad of metabolic effects. And one important effect of insulin is to promote glucose, sugar, or carbohydrates transport into the working muscles or into skeletal muscle, right? So insulin also suppresses the fatty acid that's released from what they call adipose tissue. And adipose tissue, if you don't know, that's a fancy word for stored body fat, right? So insulin has multiple things it's going to do. One is it's going to deliver the glucose to the skeletal muscles. And the other thing it's going to do is it's going to suppress fat burning. So muscle glycogen is the essentially stored carbohydrates in the muscle, if you want to think of it that way. Glycogen's an essential fuel for energy production in the working skeletal muscles. Glucose transport. So this is the another source of carbohydrate during exercise is circulating in the blood. So whereas we could be using the stored muscle glycogen here, the second part is being able to take it from our blood and supply it to the working muscles. And so that's called glucose transport. And the transport of glucose into the skeletal muscles is essential for returning those tissues back to homeostasis. And we have exercise that helps us signal this, as well as insulin. So there's a nice diagram in here, and it basically a combination of both insulin, which is causing that glucose to be stored into the muscles, as well as exercise being a signaling mechanism for getting that glucose to get stored into the muscles. Section here is basically on exercise training and the impact on healthy people and people with type 2 diabetes. So regular physical activity leads to numerous adaptations in skeletal muscle, which allows the muscle to more efficiently generate ATP. So, if you think of like one of the adaptations that folks are going to see or feel once they start working out regularly is having more energy. And it basically says it right there that, we're going to be able to make those muscles more efficiently generate ATP. And we know that ATP is what's going to fuel, or not fuel, but to provide the energy that's going to get those muscles to contract. In regards to carbohydrate metabolism, some of the key adaptations, so we're doing exercise, we're adapting, occur in the skeletal muscles. So we want to see those muscles grow, people, or at least adapt. And with exercise training, to include enhanced glucose uptake. So we're training those muscles to suck up more glucose from the body. And the more glucose that your muscles can suck up, the less is going to fat. And also the more energy that you're going to be able to create and do more things. So trained muscles are also characterized by increased concentrations of glycogen. So you're just going to store more for future things. Stamina is probably going to be a big part of that too. Exercise training causes muscle fiber type transformation to a more oxidative and perhaps the slower phenotype, so slow twitch muscle fibers, and an increase in the mitochondrial activity. We talked about that not too long ago, and the content of the mitochondria. So this we know is beneficial. Exercise training can increase insulin sensitivity and improve overall glucose homeostasis. So, if your doctor said, hey, you have high blood glucose, then, you're not in a good overall glucose homeostasis, guys. It's too high. Insulin sensitivity is that the insulin is going to be effective in signaling the muscles to do what they need to do as far as uptake of the glucose from the blood. So it's also, this is overall is a particular importance with individuals with metabolic diseases such as type 2 diabetes. Type 2 diabetes arises from a combination of susceptibility and environmental factors, including physical activity and poor nutrition. Thus, type 2 diabetes typically develops in individuals. They become more obese and less active, leading to insulin resistance, impaired glucose tolerance, and eventually the onset of full-blown diabetes. So while type 2 diabetes is a multifactorial disease, lots of things going into it, it's a disease of altered carbohydrate metabolism on many levels. So, overall, this is saying is that, we can improve our carbohydrate metabolism, then we can improve our susceptibility to type 2 diabetes. The good news is that regular and physical exercise can delay or prevent the onset of type 2 diabetes. And there's studies and things and references that they have in there, and how exercise can actually lead to those beneficial outcomes. So increasing physical activity in adults with type 2 diabetes has been shown to result in partial or complete remission of type 2 diabetes in this study. And we'd have to look at the study specifically. In 11%, and an additional 7% had partial or complete remission of type 2 diabetes after 4 years of exercise intervention. All right, guys, thanks for joining me tonight as we went through a little bit of detail on the exercise relationship to carbohydrate metabolism. I think this is an important subject that can help us to better understand how the decisions we make in life affect our overall health and fitness. Thank you guys so much for joining me. Take care. Have a good day. See you soon. Peace.